Psyched to be here with all these wonderful people to talk about this topic. I think we should just start by having everybody go around and introduce themselves. Do you want to go first?
Sure. Hello, I am Jeff. I work here at Clay on the AI team here, mainly on ClayGent, which is our AI web research agent, and a lot of our other agentic applications within Clay.
I'm Merrill, co-founder and CEO of Graphite. We're building the code review platform for the age of AI. We build Graphite agent, which scans every PR in a few seconds, gives a review like a human developer would, and also is like an agent that's live in the PR page with you that you can have like ask questions, write tests for you, have it like explain anything, like find any relevant context. Basically like a real-time collaborator as you're doing code review and getting PRs ready to ship.
Hi, my name is Atiani. I work in Datadog. I work on a few products, including distributed tracing, database monitoring, as well as observability for large-scale data pipeline. Over the past few months, I've been focusing on how do we enable our customers to resolve incidents faster through automating some of the root cause analysis in incidents. Specifically, I'm focusing on resolving issues with databases as well as with latency issues in API service.
Hi, I'm Alex. I'm the founder of Stainless. We make quality fittings for your REST API, which is vague. But we make the OpenAI and Anthropic SDKs. So if you run pip install OpenAI or go get Cloudflare or npm install Anthropic or anything like that, you've downloaded code that we generated. And we also make MCP servers and all sorts of interesting things related to that, which involve some agentic components, which we may talk about more.
I'm Fernando Rojo. I work at Vercel. Earlier this year, Vercel acquired my startup, and I joined as head of mobile, where I'm now working on the mobile app for V0. So most of my time recently has been around V0, which is Vercel's AI product to let you chat on a website. And next to the chat, it creates a sandbox website for you. And you can then continue that website in your own repo or continue building it directly from the browser. And you can get a fully functioning Next.js app.
Sweet. So I think a good place to start is obviously agents are hot. That word is hot. But agents are not always the right solution to whatever problem you're facing. So I'm kind of curious for us to discuss, when should you build an agent and when should you not?
Yes. So just to give some context on Clay. So Clay is mainly a tool for data enrichment and data orchestration. If you think about a Clay table is effectively a directed acyclic graph of enrichments. And so, and many of those enrichments, I'd say like over a third of the enrichments that people will use in Clay end up being agentic web research or other types of agents. Typically, we see that Clay users like having the observability of the orchestration being done on a deterministic layer and then having the actual execution of individual steps being done by agents. And so there's sort of a consecutive circles of control, but at the orchestration layer, we typically see people like that observability.
Can you explain that a little bit more? Like, give me an example of what's happening at the orchestration layer and then what's happening at the sort of agentic, the agents that are being popped off by the orchestrator. And maybe you can use that one so we can go back and forth a little bit, unless you want to share.
Yes. So I think you can think of Clay users effectively as designing these workflows where you might. I think like we see users, and we think about this a lot, building these agents, building agents where what's the difference in quality between 90 and 95%? And those marginal increase in quality, like, does that matter? And I think like for Clay users, they're effectively building workflows around these non-deterministic endpoints. And so already you have to build these off-ramps for, when the agent gets something wrong, how do I control for that loss in quality? So an example of that, right, is you can use a Clayagent column to research, recent funding announcements from a company. But Clayagent might not be able to get that. But something like Crunchbase does have that information, either from non-public information, non-public sources, or wherever. And so you can imagine one of the core Clay products is this idea of a waterfall. So start with an agent, agentic web research, and then fall back to a potentially more expensive but deterministic and correct proprietary data source. So that's kind of, I think, where users still like having that top level control, but then falling back into this sort of agentic.
Got it. So one of the things is observability and control. I think another thing that we've found, so one of the products that we build is called Cora, and it manages your email with AI. So it sits in your email, and it decides when emails come in. Is this an email that you need to see immediately? If it is, you see it. If not, it archives it, and then twice a day it sends you a really nice summary of like all the emails that you need to see, but you don't need to respond to. So it makes your inbox a lot quieter. And we added in like an inbox assistant to that. So you can chat with it and you can be like, okay, when is my flight today? And it'll go find it. And it's an agentic thing. And when we built the agent, we were like, wow, this is so sick. Like we got to replace all of our like hard-coded functionality with just like calls to the agent. And so like one of the features that we have is when you get your brief in the morning or in the afternoon, we have a little like return to inbox button because it summarizes your email. So you can be like, okay, I want you to return to inbox. And it used to just be a thing that actually just like went and did the thing with deterministic code. But because we had this agent, we were like, we'll just send a message to the agent and then it'll just like fill it into the agent. And we thought it was really cool, and all of our users were like, this sucks. It's like so slow. So I think that was a lesson for me about, like it's really cool you can do this, and it's not always the right tool for the job because it takes a long time. It's also expensive, but it's expensive for us, but it's also it takes a while, and sometimes just having the deterministic code for something like that is better.
I actually have a question. It's interesting parallel maybe to Merrill and Graphite, where it seems like maybe agents are better at kind of reviewing or categorizing or tagging like this kind of list of things. Curious if that resonates as like a, for code review, is that similar? Like, maybe a pointed question, would you ever do sort of agents to actually fix the things that your code reviewers are suggesting?
Yeah, it's a good question. I think there's a lot of parallels in anytime that you have to like traverse a graph or like explore many different options, like that ends up being something that agents are good at. So for code review, for instance, you end up traversing a lot of the file tree and finding the right context there. You end up looking in the linear ticket associated with it. You look at like Figma mocks if they're attached, like what was written in the pull request description. You have to, and sometimes the context lives in one of those and all of those, and you don't know it's very hard to sit down and define like first look here, then look here. It's really case by case. So for something like that, building an agent makes a lot of sense. I think if it's something that's more deterministic though, like you just want to look for this pattern in, if you're, say you're building like a security scanning tool and you just want to look for like a regex pattern, like obviously something like that is going to be much easier to just write determinate. I mean, that's a simplistic example, but something more deterministic, you don't really need to throw agents at it. And if anything, it just needlessly complicates it and makes it take a lot longer than it would just writing it deterministically.
I agree that in many use cases, using an agent overly complicates something that could be done with deterministic code. But one comment on something you mentioned you built something and your users did not like it because it was slow. I think for me, one thing a pattern that I've been seeing often a lot is what matters a lot in agentic software building is, first of all, building something that works, and then understanding the quality of it in a systematic way. And then after doing that, there's a lot of different tools that you can use in order to improve the latency, like using smaller models with distillation and fine-tuning that give you the latency that you want after you have established the quality. So that's one pattern I've seen a lot.
Yeah, I've seen that too. Like, I think the general pattern is like use the most powerful model that you possibly can, especially when a new one comes out. It's just like go to the new one, even if it's really expensive, and then once you've gotten that use case, once it works, then you can kind of break it apart into smaller pieces and hand it off to, smaller models, cheaper models, or maybe even deterministic code. Is that sort of what you're saying?
Yeah.
Yeah.
And to that point, for security scanning, for example, it's perfectly fine to start with something that does logic scanning, looking for PII or scanning for sensitive information. And that's how we started in Datadog with our sensitive data scanner. But what we ended up doing later is that we used that Logic's baseline to train a small language model to do our scanning in real time on large volumes of data cheaply. And that performed better at catching more sensitive data than a simple logic scanner.
Did you have something you wanted to say?
Sure. Who here has written React before? Okay, so a good amount of front-end people. So are you guys familiar with the concept of an error boundary? Okay, so basically if you have, let's say, a button or any component that breaks, you can wrap it with an error boundary. It's kind of like a try-catch, but on a UI level. And in terms of an agent, this was something that V0, a product for like essentially vibe coding, had, which was we would generate a website for you, and then there would be some error. And so the most clever thing we could do is just wrap your app in each screen with an error boundary and then show you a red pop-up. And then you would have to click fix. And that's a really bad experience because you're sitting there waiting for all the tokens to be done, and then you end up with just like a red banner. And so what our first agent product, like we just rewrote V0 recently to be an agent, is it actually will run the website for you before it ever shows up to you. And then it'll screenshot the website. And then we have another agent that looks at that image and looks for padding inconsistencies, issues with letter spacing, discrepancies in casing, all kinds of things that would make a website not seem very polished. And then after that screenshot, it actually reviews, it clicks around the different links, it sees all the different things that could go wrong and tries to fix them eagerly. And it also can actually address errors and listen to both the server-side and client-side logs and feed them back into the agent. So all that to say, for something like generating code, you can get a lot of deterministic outputs from the thing that the AI gave you and figure out if it's doing a good job or not. So that's on like the code gen side. But we also then have an agent for deployments, right? So if you get build errors, we actually can pipe that right back into the context as well, and have another sort of task for fixing that. So we've just found like dramatically higher deployment rates and way lower error rates. Like we're talking like huge jumps since we started doing that, and sometimes it'll even do like 4 generations. It's just a much better experience than having the person be the agent and go in and click like this errored.
So the general pattern is like allow the agent to close the loop to see the results of the thing that it's building, and then like run on those results to improve its output.
Yeah. Plus like the agent tools we built, ultimately a lot of this is just like patching things, right? So we make this thing and we realize like, 80% of the errors it makes is of this kind. It's like a visual one. Okay, let's make like a visual agent, something that screenshots. And then, the corner radius is always wrong in this way. Like, okay, let's make sure that gets reviewed so that it's consistent.
It really strikes me. I'm excited for everyone to learn more about some of the things that Samar is building at Datadog, because I think they're really interesting. It sounds like they've gotten some pretty impressive preliminary results. And what I've heard when we spoke before really reminds me of what I'm hearing now, where what really worked to build quality production agents that are useful, especially at least in a software development, broader context, is doing a lot of work and actually writing a lot of code and writing a lot of very prescriptive prompts. So, Samar, I don't want to steal your thunder, but getting very hands-on with, okay, now that we've gotten to this point around analyzing the latency of the database queries, now we're going to do an explain analyze. For example, I don't know if that's an accurate example, but
for context, there are 2 hypotheses that we are testing in Datadog right now when it comes to doing automated root cause analysis. The first one is an open-ended investigation where you're there's a monitor that triggers. You have an agent that responds to the monitor triggering. It's looking at the details of the monitor. It comes up with its own hypotheses, and then it tests those hypotheses in parallel, given all of the telemetry that Datadog has for you. That's one hypothesis. The other hypothesis that we are testing is, what if you can define a problem, a very narrowly defined problem, like latency of API servers, latency of API endpoints on API servers, and in a microservices environment, and get really, really good at understanding the cause of that latency in that environment. And you ask a set of human experts to come up with an investigation flow in that case. So what might it look like in this case? If you have an increase in latency in an API server, then one thing that you might do is that you look if there's a deployment that happened on that service, if there's a change in the traffic patterns, if there's a feature flag that has been turned on, if there's a change in the infrastructure underlying that service. And if the answer to that question, to all of these questions, unsatisfactory, you might go down the dependency tree of that service until you find a satisfactory answer to that question. And maybe you would reach a database and then the query with the problem. And then that has its own investigation flow that can be designed by a set of human experts. So that the second hypothesis is that if you define a problem narrowly enough, a set of human experts can come up with an investigation flow, and you can do that over and over and over again for a large number, but a bounded set of problems that human beings face in production environments. So we're testing both of these hypotheses. I'm specifically working on two problem domains: the latency on API servers, queries, and relational databases. In our own evaluation, in which we came up with a set of examples given from our own internal incidents, we've seen that this approach gives us 80% success rate in identifying the root cause. Now, of course, there's a question on whether our internal data set is representative of real-world environment. There's a question. That's the main question. But so far, this hypothesis seems promising, and that's what we're working on.
Yeah, I mean, like, if 80% of the time your latency regressions could be automatically diagnosed by like an AI agent, like I think that would be like, I'd be pretty shocked. Like that's really impressive to me. And the fact that the way it was built was basically, you do a lot of engineering. Like that's interesting. Like that's different from how I think a lot of people would preconceptualize what it's like to build an agentic application, which is mostly figure out how to throw some AI into a loop and actually have the loop run for a while. And then, step 3, profit, right? Like actually, step 2 involves just like a lot of engineering of like, oh, actually Vercel happens to know a lot about padding alignment on buttons, or whatever. And that knowledge is like really actually imbued into the product, which is interesting.
Yeah, I mean, that's one of the very intentional things, at least behind our product, is like we literally want it to be a knowledge transfer. So we like tap like the best engineer of like sandboxing or something, for each sort of thing we need to do in this product. And it's not just for V0, like we have a number of other sort of like AI sort of products that this is the case for. Like if any of you want to hear us use like the Vercel AI SDK for like building your own AI app, or something like the AI Gateway, which if you've used the AI SDK, it's a way to basically wrap any model with a common API. And the gateway is just a way where you can change the model with a single string. So you don't actually need API keys or anything like that. You just give us one credit card. And all those came out from us building our own product and then spending all this time on engineering and building all these abstractions internally, and then just being like, okay, we should probably pull this out because it doesn't really belong in product code. It just more belongs in a library.
We had a similar experience building Graphite agent where I think in the beginning we tried the naive thing of like, let's just throw an agent at it, put it in a loop, have it generate, like read the PR, generate code review comments. And The result of that was a lot of just annoying comments and like a lot of noise. A lot of it asking you to add a comment on top of every single function definition, like things like that that just annoy most developers or are just completely irrelevant. And it took us a long time of like deconstructing, like, okay, what are the things that make a code review comment useful or not? Like, what are the types of things that we want to be commenting on or not commenting on, and breaking those up and making those all like sub-agent critics essentially to get down to a review and a set of final comments that are actually useful. And that, coming to that and figuring out like what order do we have that happen in, like everything that goes into like feeding the right context to get to a quality review took a lot of engineering effort. And even now there's still, every time there's new models, we're tweaking that. Every time we're connecting to new sources of context, it's like a similar question of like, how do we architect this? Another interesting example is Graphite Agent in the PR page, you can ask it to make edits or write tests. Fix failed CI is another thing it can do, but you have to, in order to give it the right context, we basically had to build a virtual file system in the browser just to hand it to the LLM, because the LLM is trained on browsing a file system. And if you just hand it the PR diff or like the set of diffs, like it doesn't do as well as if you give it like a simulated file system. So there are all sorts of like little interesting things like that, but ends up being like a lot of work that goes into building the right context.
I think you're totally right. I think that's one of the things that seems to make Claude Code so good, is that it used the file system, and it's just one of those weird anachronisms of the way it was trained. Yeah. Did you have something you wanted to say, Alex, or should I?
I finally came up with an answer to your question.
Which question was that?
When should you and when should you not try to build an agentic application? And it's like kind of a stumper, actually. Like I don't think it's that straightforward. But there's code that you can write that's you just write code, right? Then there's code that you write that makes a single API call, or roughly a single API call to maybe retry, right? To an AI, to an LLM, and say, hey, please perform probably a very tightly scoped task. That I can, take the output and reliably use it. So either I want free text or I want like, some pretty scoped bit of JSON back. And then there's stuff where you're like, no, I want you to go off and do a bunch of stuff, right? And that's when you're building an agentic application. And that's actually like, as we kind of talked about, it's pretty rare. Like the glib answer to that is avoid it at all costs, right? I think a slightly more useful answer is build an agentic application when otherwise you really would need to throw humans at the problem. And AI actually might just work in this case, which is a narrow, overlap of a Venn diagram.
Yeah, I think that there's a way to another lens for that is when there's an extremely long tail of different things that you might ask the thing to do, and it's very hard to predict. Is another way to think about when you might need an agent. I am curious though, like one of the big problems that I have just internally is just like knowing what the hell these agents are doing and like how people are liking them and where they fail. How are you all thinking about that and solving it?
Yeah, it's a very hard problem. I think we spend a lot of time effectively looking at traces and looking at online evaluations or online kind of categorization of different prompts and different sort of threads of traces that get aggregated together. I don't think it's an easy problem. So I think we've spent a lot of time effectively building classifier prompts for online evaluation to try to, one, understand use case, and two, understand, hey, is this actually accomplishing the goal that the user stated? So you sort of have this dual layer of, one, just have offline evals to understand that, hey, do we have regressions in what we're doing? But also just online evals of, hey, is this actually accomplishing the goal? You can look at metrics as well, usage metrics, but those can be quite deceiving. I've found that, people will use stuff even if it's broken. So it's very hard to, actually, you do actually have to look at traces, and you have to look at, I would say down to the level of what am I sending? What context am I aggregating?
Are you sorry?
I'm curious.
Are you using like specific libraries for that or specific tools? Like what are you using? And maybe you can
Yeah, so we've tried a couple of things. We use Langsmith primarily for observability, and we find that to be pretty good.
Cool.
I think we're in the unique position of, well, not unique, but we use the Vercel AI SDK, and we use Langsmith for observability. So we're not using LangGraph or LangChain or anything like that, and that actually works quite well for us. I think one, the Vercel AI SDK is extremely great piece of technology. So props to Vercel for creating that. But I think it is really helpful to have just this observability tool that aggregates all these LLM or actual AI calls together. I think
Going back to your question about when to build an agent and when not to build an agent, you mentioned maybe a heuristic is when otherwise you'd throw a human being at the problem. And the way I'm thinking about it right now is I'm comparing what happened with Devin, which was trying to completely replace a human software developer, versus what's happening with Cursor, which is trying to be kind of like a co-pilot. And I think Cursor doesn't fit the mold of anything that we use today or even an assistant that we have today. It's more of a brand new category of tool that you have at your disposal. So right now, I think with the current state of the art of technologies, I think the most compelling use of agentic technologies is kind of like an additional appendage or an additional organ in your body that you can use to get things done. So, yeah.
Do you not think that as the models get better, the fully agentic background agent model is going to be the one that takes precedence?
That's a big if. I think there are several possible trajectories in the future where there's a trajectory where the current capabilities are more or less what we get in terms of ability, and there's incremental improvements over time. And there's a trajectory that I believe where there's exponential improvements, and the improvements that we've seen in the past few years are repeated over the next few years or even more. And there's everything in between. So I don't know. Depends.
I personally think it's really fun to build an agentic product. I think it's really cool to see what it does and to follow all the steps. I actually really liked when Claude Code first came out, just seeing everything that's going on, and like the fact that it's in a terminal just means they can't display none anything, and I really like that. It's like a bit overwhelming maybe, but just like the whole to-do list and getting full exposure and peeling behind, I feel like as an engineer, I really like that. And for me, like assessing if it's a good idea to like have a product be agentic, at least I found for V0 it's very useful that we have kind of like the mix of data and vibes. Like for me, the vibes is like I'm using it, and does it, is this week better than last week based on those changes we made to the prompt? What are people on X and Reddit saying, and like what does our Slack look like? But more specifically, like every 4 hours we have an error rate percentage that gets sent to Slack in the dev channel where we're pushing PRs, and so it's hard to miss. It's like we know the percentage of builds that didn't work today and in the last week, and how that changed from the previous one. So it's just nice to like have the mix of those two things together.
So crucially, the error rate is like that's a deterministic thing.
Yeah, exactly. Like you can really assess like, oh, did this change really bump things? Like the error rate went from 4 to 2%. Like,
do you have anything else that's for specifically like? It's not a deterministic thing. It's like, did the model did it make something that I thought was awesome? And I know you said you have like vibes you're monitoring X or whatever, but like, I'm curious if there's any other like harder way to do an eval there or like, yeah.
Yeah, I mean, this is that's just the trickiest one, right? Is like, is someone actually, one, are they happy with what they made? And two, like, should they be? And like, really, it's a lot of manual, just like actually just like assessing feedback from people constantly. And like we're talking to like, doesn't matter the size of the company, right? Like every single person, every engineer on the team is talking to like customers constantly. And like everyone, there's always someone who's trying to respond to any inquiry, whether it's like customer service or literally on Twitter within minutes. And so it's hard to get the whole fire hose. Like if no one's sending you anything, it's hard to assess. But
Do you ever have times when the data and the vibes are in conflict?
yeah, of course.
This is like something that we've seen a lot where sometimes we'll work really hard and we'll improve we look at like acceptance rates of code review comments of if Graphite Agent leaves a comment, does it actually lead to a code change underneath? And we're now like slightly better than human developers on average for Graphite Agent. But sometimes we'll work really hard and we'll get that number up we'll look at a specific customer account, we'll work with them and their code base, like try to get that number up. But then like developers will report that they feel like it's performing worse. And it's like sometimes making those two things like square like is very difficult.
Yeah, I mean, in the case of like a vibe coding tool, like a low error rate is like a necessary but insufficient condition to making something good. Because like I could just get rid of all errors by making like a black square. So like there's definitely a risk to making it too simple and having it dumb things down because you are looking for something to give you new ideas.
Another tool that we've used that I kind of like, I'm not using it like every day, but I think is pretty cool is Raindrop. Have you guys tried it? Yeah, you basically you can do like it gives you observability into the prompts and responses that you're sending and the agent is doing, and then you can sort of do AI summaries of those things. So you can be like, for this type of query, what generally is the response, and it gives you a pretty good view of that.
Do people use a thumbs up and a thumbs down button?
Yep.
Is it any good?
Yeah, it's quite helpful.
That's a big one. Yeah.
We have I guess rage detection thing that if someone's upset, it'll be like, I've just reported this to the team.
Yeah, I mean, there's a scan on every message.
So like when my mom's in ChatGPT and she's like, "No, you're doing it wrong," in all caps.
Yeah.
Like when someone's in Cora's email assistant and says that, like
it says, "Hey, we just reported this to the team," and then it sends a Calendly link and it's like schedule a time to hang out with one of our engineers. Yeah.
Is there like a what's the opposite of like a rage detection? Is there like
just like detecting sentiment?
Joy.
Yeah. Like I'm sure sometimes when people are using V0, they're like,
I'm never
like
thanking anyone.
Like, oh my gosh, this is incredible! I can't believe how amazing this is.
The problem is like the second I'm happy, I'm no longer chatting because like now I'm sending it to someone. So it's we're just we can track that kind of stuff, but like, does anyone here ever say like, "Thanks, man"? Like, yeah.
Good bot.
Good job, robot.
I always say thanks to my Waymo. So yeah.
Never know.
You never know.
For next time.
Cool. I am curious, just thinking about agent architectures for a second. One of the like interesting design choices that I've run into is something that I call big boy versus small boy architecture. And the big boy is just like one big prompt that does everything and can go down any kind of branch. And then another architecture is like an orchestrator with a bunch of subagents. And there's trade-offs. Like I think the big thing with the small boy architecture is passing context back and forth is really complicated, especially if you're doing it with models that are from different providers. It makes it really hard. But with a big boy, you just like get the prompt just gets like way overloaded and then it sucks. Curious if how you guys have thought about it and when you go with which one and how you've solved those problems.
One potential way this is something that's highly tentative, but the current way we're thinking about it is that you'd have an orchestrator agent, and the way that the orchestrator agent would work in the context of incident response is that it would understand the nature of the problem and then delegate that problem to the agent that it knows is best equipped to solve that problem. So latency to latency agent, database to database agent, and on and on. And in this case, the context that you are passing, it looks more like a tool call than it is passing the entire conversation because every agent is doing its own queries and building its own context based on that call. So context passing is so far not a problem, but it's also a very specific problem, very specific use case for us.
That actually, this is a super tiny aside, but I am curious, has anyone used up here or out there an actual like MCP tool of call another API, another AI API? You know, like do people ever actually just use that as an MCP tool or as a function call?
I've done that in Claude Code for calling O3, but you know that was kind of a kind of helps. I think O3 is better at debugging some stuff. So I don't know. This is me, personally. But.
Why? Why are you asking that question? Like,
it's so we work closely with Anthropic and we do their SDK, and we also make MCP servers for people for their APIs. And we were like, hey, Anthropic, would you like us to make an MCP server for your API? And they kind of like stared at me and they were like, that's ridiculous. And I was like, oh yeah, that is ridiculous. Like that would just be an MCP server for AI when you're already in AI. Like what is the point of that? But actually the point of that, right, would be the small boys, but I've actually never tried it myself either. So I was just curious if that was like a legitimate architecture that just works well. It's just been a small thing in the back of my head, but
I think there's a bunch of enterprise tools, for example, that where enterprises might want to build their own agents and have that agent be able to access their own information. For example, Datadog might have an MCP server that allows your internal agent to query Datadog telemetry. Confluence might have an MCP server so that it can answer questions that whose answer are in documentation. Segment, which is an audience management tool for marketing tool, can build an MCP server and make it available for your employees to. So it could be kind of like an enterprise connector for your tools, and at least this is how I'm thinking about it right now. And that's the most compelling use case I've seen so far for MCP servers in the world.
I think, yeah. I mean, to the question about is it one long prompt or is it kind of a bunch of sub agents? One of the things about Clay is we have just a decent amount of scale, and because of that, so we run around 200 million agent runs a month. Because of that, we're very cost sensitive, and so the latest frontier models give extreme levels, like just big discounts if you use caching. And one of the advantages of kind of having a single loop is you get the advantage of latency. If you hit the prompt cache, like it's much faster, and it's 90% cheaper for input tokens. So it's like you kind of have just this double kind of advantage of doing that. So like there's we really have to think about if we go to a sub-agent loop. Yeah. There's a lot of downsides to that.
On the flip side, though, if you have, for us, one of the reasons why we broke down the critics into sub-agents was that it actually lets us run a lot smaller models. So for this, because we're generating a ton of comments and we're running a lot of tokens, like every single review takes like a ton of tokens to get to that, and running those all through like frontier models would drain our balance sheet pretty quickly. So we had to architect it in a way where we could choose like when do we use the high firepower models, and when can we use something that's like a little bit lighter and doesn't cost us nearly as much.
How? How did you do that?
A lot of it was like evals and like testing where we could we started with the big models everywhere, and then we steadily like looked at, okay, can we drop this in? Can we edit this and maintain quality?
Is it like hard coded? This is something I've been wondering. How dynamically can you decide when something should go to a frontier model versus a medium model versus a nano or whatnot, and especially if you're potentially routing between totally different providers across the different tiers, like how you think about approaching that rather than
We just hard coded it. I think there is like a level of like another level of advancement, and like OpenAI is doing this with their model routing now, kind of natively, of like what model to use for a very specific query. But for us, I think having the repeatability of like it's pinned to one model, we know that that's like a variable held constant. That's something that we wanted to have and like maintain consistency as we iterate.
Yeah, once you have like a specific role, then you can set it, sort of say, okay, the orchestrator is GPT-5, but then the writer or the evaluator is Claude or whatever, and that seems to be helpful. But yeah, there is this pattern happening now with, like you said, with ChatGPT, but a couple other people are doing it. So Warp, for example, if you use their terminal, they'll flip between Bash and like a prompt, then they have some sort of classifier model that decides. Same thing with Arc. It's not the exact same thing as GPT-5, but like I think this dynamic routing to the right model is starting to happen, and it's useful.
How did you design your critics? What kind of roles did you assign to them?
They all have like very specific like things that they're looking for. So there's one that's like, is this comment like asking us to just add a comment on top of every function? And we say like, okay, don't add that comment. Trying to think of some other fun examples. There's just some things like that. That's a specific one, but there's a whole class of, we actually interviewed a lot of our developers and a lot of our customers for like what types of code review comments are like, do you find this comment helpful or not helpful? Would you want us to write this? And then tried to classify those and then take the common answers one way or another, and then convert each of those into critics. And we're always playing around with like adding new ones, taking some away if they're redundant. That's something has been a source of like continuous improvement for us.
Yeah, I think one weird piece of all this, though, is like as the models get better, they're also just directly trying to address a lot of these problems directly, right? And so you saw this like before we had thinking models, everyone was basically simulating thinking, and then like O1 just like wiped all this away, and O3 like this is just going to keep happening. And I think like when Grok's latest model got released, like it only worked well with code when you just dumped in like your entire massive repo in one text file into their text box, because they were kind of building this whole sort of agent style thing themselves. And so that's like the weird thing to look out for, is you do want to also be ready to like not over optimize too much, because it's going to get fixed upstream.
Totally. I've had that before where we built this like gigantic, crazy, like Rube Goldberg architecture, and then the next model just like one-shotted it, and we were like, fuck. And so, I think like when you're working with these models and you have to have some very complicated system to like figure out which model to use in which case, you should like really take a beat and be like, does the improvement curve mean that in 6 months this is not going to be a problem? If so, I should just like wait.
Yeah, at the very least, just make it very quick to switch your models, or to, to like have your steps. I mean, like you could abstract in somewhat of ways that your orchestrator isn't like overly difficult to update. Like make sure to change your model, you should really just be changing a string.
This is a subtle plug for the Vercel AI SDK.
You should try the Vercel AI SDK.
We've got like 10 minutes left, so I want to open it up to questions. Does anyone have a question they'd like to ask? Yes, go for it. So the question is, are there tools that we've used in our workflows, whether there are developer workflows or in the workflows that we're building, that I guess have helped close the loop in sort of the same way as Vercel? I'll say like using Claude Code, one of the apps, Cora, like the guy who runs Cora, the GM of Cora, his name is Kieran, and he's just like this agent pill, like he's running like 10 of them at once, and he's like he's amazing. And so the whole repo is set up with all of his presets, and I've been building a feature in Cora in between meetings, which is really fun. And one of the things that is so cool about it is he has Puppeteer set up. So it's similar to Playwright. And so if something goes wrong, I just say, hey, can you fix it? And it kicks off a subagent that like opens up Cora in a browser, and then I just like watch it go back and forth, and it's like magic. It's wild. Another person at Every who runs Spiral, which is our ghostwriter, he has this really interesting setup where he has when he's trying to make a design look like something that was designed in Figma. He has a system where he has a coding agent that makes the design, and then a reviewing agent that takes a screenshot and then critiques it, and then they go back and forth until it's good, and it works really well. And all this stuff is really easy to do with Claude Code.
Yeah, I use a tool that's sort of similar for mobile development. I don't know if anyone here does mobile, but there's this tool called Radon IDE, which is really cool. It like goes in VS Code or Cursor, and it's as if it were like Playwright, but it actually is a real like simulator for iOS, and I think also Android. And so you can like it'll actually run the app, and you can both interact with it directly, but then it also can run automations in it right there for you. It's really cool.
The question is, has anyone done the cost analysis to see whether it's cost effective to be using open source models, especially when you're using these things at scale?
Yes, I'd be very interested actually for the rest of the panel as well. But yes, so we use open source models pretty extensively, mainly for cost reasons, but also the performance has gotten a lot better very recently, I'd say in the past 3 or 4 months. The Qwen 3 series is fantastic. K2 is great. GLM 4.5, like these are all great models. So yeah, I'd say also, specifically for the re-rank and embedding models, like Qwen 3 is very good. I think it's at the top of the leaderboard still, and it's very cheap.
So would you say like most of the workload goes to like open source model, but then you still have some that goes to like OpenAI, or is it mostly open source?
I'd say it's the reverse. So we're still sending most traffic to frontier models or the main, OpenAI, Anthropic, Gemini. But we do pretty healthy open source workloads at this point, and I'd say we'd probably continue to invest in that over time. The performance has, I would say, recently basically started to match frontier models. I'd say it was like, I forget exactly if this was like June or July, but 4 or 5 different models came out. There's K2, GLM 4.5, the Qwen 3 series. It was just a lot of them came out very quickly, and they're all quite good.
Cost-wise, is it like a lot cheaper than just
Yeah, so K2 I think is on the order of like 15 cents per million input tokens compared to GPT-5 is $2. So it's an order of magnitude less.
I feel like it's always a good sign when the open source starts catching up, because then I'm like, oh, there's going to be a big jump soon.
Yeah, I'd say GPT-5 is still actually better than those models.
By far, but
Yep,
anytime it like starts to creep a little bit, then I just feel like the frontier models get so much better, like within 2 weeks.
Yeah, the fun thing about K2, which also K2 just had a new, they just updated their weights, I think a couple days ago. But the fun thing about K2, it is a non-reasoning model that is reinforcement learning trained on the base weights for coding. They have an Anthropic compatible API, so you can use it in Claude Code for an order of magnitude cheaper than Sonnet or Opus, and it's very fast. So just a fun plug for your own developer environment.
Hi, I'm Lucas, founder of fallbacks, or an AI spreadsheet editor, just like Cursor for Excel. And so when you were talking about like the rage detection algorithm, we have like bankers and financial analysts using our tools. And so like in pilot right now, like bankers get very upset when like things don't go their way. So just like everyone knows the Wolf of Wall Street type thing. So we're like building kind of like a pseudo like therapy agent, but I love your idea. With I know it's not great, but hey, I just I got the poncho, I got like give somebody like a toy to keep them calm. Okay, basically, I love your idea about like scheduling that meeting. Something I'm curious about as we're building our MVP is like, what's the actual opportunity and reality of building an agent to close that loop entirely autonomously? So an agent picks up the Calendly call at 3:30 in the morning. That Goldman Sachs analyst has a model to give to their MD at 6 a.m.
Aren't you building that? Like, shouldn't you tell me? I don't know.
A better way to follow was like, in your experience, like with developers, how fast is that loop closing for you? What KPIs and business drivers are you evaluating to see that you can actually solve your customers' problems? It's super interesting to me because I am.
Oh, that's a good question. I would say like we're probably not doing it that well right now because we're a team of 15. We run 5 products. So there's a lot going on, and I think we just hit a new level in terms of like we've grown MRR double digits in the last couple months or last 2 months straight, and so we're just starting to hit a like inflection point, and so it's becoming a real thing. And I'm like, okay, we should probably figure out how well we're doing at solving our customers' problems. So we're starting to build processes like that, but right now it's honestly just my vibes, like going into our support forums and looking at our Discord and all that kind of stuff. I think it'll be better soon.
Let's go bowling.
My name's Sebi. I work at Spotify as a PM. One question, a little less technical, is when you all are thinking about, say, MVP, either a net new agent or something that you're adding a capability to, does that validation cycle change from your typical, working in Figma, going and testing with users, or how do you validate that cycle with agents?
And are you talking about like market validation or technical validation, like that it actually works?
More market validation.
Okay.
How do you go seek out those users that you think this is something?
Cool. So the question is, how do you do market validation for agents?
For me, as somebody who's been working a lot with customers over the past 6 years on building products in Datadog, it's different. The main difference for me is that there's a lot of, in the classical model, we're much more comfortable finding design partners to build an MVP that is maybe not very well polished, and then ask them to install it in their development or staging environment. So, and establish a quick feedback loop with customers, and that's how we iterate quickly on building the product. But as we're building agentic products, I've found this model to shift a bit, where we're spending a lot more time internally building good evaluations of the agentic capabilities, getting confidence in them before we start testing them with customers. And that might change in the future because we're still learning what is it that we can build that will actually work really well, even if on our own internal use cases, before we start exposing it to customers. That said, a lot of our customers are super enthusiastic about trying it out, and in those cases, we do share we do share those features with them and iterate with them on it. But in my opinion, at this stage, for us, the most important thing is establishing good evaluation and trying to see what it takes to get to a good score. At least that's my own experience.
We have a very specific way that we do market validation, which I think is like it's sort of very of this moment, because I think of AI as having like reset the game board for like all of the opportunities in software. Like if we were doing this 5 years ago, I think B2B SaaS had sort of like picked a lot of the like obvious ones, so you'd have to go a lot deeper. And now there's just like everywhere you look, there's something to do. And the way that we do it is we have this team internally. Everyone's like very AI people. We're all like AI first for engineering, writing, like anything that's the first thing that we think of. And what happens is we just see problems that we have, and you build something for yourself first. If you use it, then you try to spread it to the team. And if the team around you starts to use it, then we have an audience, and we publish, we write about it, and we push it to the audience. And there's a really good chance that if you like it and then the team likes it, that the audience is going to like it. And so that's sort of how we do our development loop.
I'd agree with that. I think the cycle times have just shortened dramatically, even in the last 6 months. Like I think to your point around traditionally you'd spend time like writing out the product spec and like going to Figma, like iterating on that a few times, and then testing a prototype internally and then giving it to some users. Like a lot of that's just been compressed now into like a month or less. And like we're at the point now where we're not writing PRDs for anything. We're doing like very high level designs, but a lot of this is just happening like live of like what we're building. We give it to customers pretty early. We're testing, we're trying to like get things out in the hands of like some initial more AI pilled users as quickly as possible, and then just iterate from there, because like if we don't, I think the market's just moving so quickly that somebody else will ship it before us.
My name is Vercel from Sledge, the founder.
My question is really about while they were building all of these agentic experiences, what have the experiences been with the agents framework itself? I'm imagining you're not just writing a native kind of API call and then looping through that. And so maybe feedback around frameworks like, like Acme or Crew AI, or like any of these agents frameworks. And what have you found in work and not work in these high intensity production environments?
I would say actually that I think using the SDKs is actually pretty great, and a lot of credit to Alex on that. But I think to Fernando's point, model swapping is quite helpful. But I think this is the approach that we take at Clay, which is effectively the frameworks are great for model swapping, but any abstraction beyond that is just not super helpful at this point. I think there's there's starting to be some, nice primitives around durable execution, potentially streaming updates to a front end. So kind of, having that layer be taken care of for you. But, a lot of these architectures tend to be, running an LLM in a loop, passing context back and forth. These are kind of language constructs, not necessarily, agent specific constructs. And so, it does end up looking more like a TypeScript or Python program than it does, specifically an agent problem. So that's the approach that we've taken is, effectively offload model swapping, but that's it.
I think we're pretty much out of time. Thank you, everybody, for coming. This is amazing. Give it up for our panelists.